what I was going to talk about before this whole thing happened, it's kind of actually, right, this is what happens. Welcome to the real world, as they say. How many of you know that the Sahara Desert, like 5,000 or 6,000 years ago, actually people lived there? There was like vegetation, there were animals. Did you know that? Yeah, 5,000, 6,000 years ago. Supposedly before and then something happened, I don't know, whatever that thing is. And, that's kind of... Oh, you think I'm not sending out to the projector? All right, we could try that out.
No, if you go into your display.
Oh, display preferences. Hang on, we're doing science now. Oh, displays.
Everyone's been coming out. Oh, thank you all for your patience.
So what happened, to the desert? I mean, what happened to the vegetation? What happened to the people? Well, change happened, right? Or as we like to say in ops, shit happened. And then, if we actually look, this change is actually everywhere. We're changing. Like, the reason that you're actually able to hear me right now is because, my body is changing. There's the air between us is changing, it's vibrating, your eardrums are changing, the neurons are firing in your brain, and so on and so forth, right? So all that, like our ability to communicate, is based upon our ability to change. Okay? So, and if you start to look, change is everywhere. And there's something even more fundamental, like, why do things change? Does anybody have any guesses? Things always change. So that's the reason they change? Okay. They can't not change. Entropy? Entropy. So, you guys are all right. Basically, things change because they're changeable. Like, things have this innate property of being able to change. So it's kind of a subtle point, and you might be wondering, what is this all about, and why is this actually even interesting or useful? But, all compounded things, compounded meaning like things that are put together, that have two or more parts, are changeable, they're impermanent. Can you think of, I can think of a few systems that are, compounded. I think most of the systems we work with have like billion. Did you know that the new Xbox processor has 5 billion transistors? 5 billion transistors. Okay? A lot of things can change in that. And in fact, if you actually think about computing, so we also often think about change kind of negatively, like, oh, who moved my cheese? Like, who broke the system, right? The post-mortem, right? Something changed. Who did it? How can we make sure it doesn't happen again? But if you think about computing, the reason computing works is actually also because of change. Like zeros changing into ones, ones changing back into zeros. Like that state change, that transition, state transition, is required for computing to work. So, okay, what now? Basically, change is the root cause, sorry, not change, the changeable nature of things, that impermanence, is actually the root cause of both all functioning systems and also all malfunctioning systems. Let me try to say it another way. Basically, like, in order for the system, your system, any system, and as we were talking earlier, when we talk about systems, complex systems, we mean, hardware, software, people, everything, sort of more holistically. So for any system like that to stop functioning, to start functioning, or to continue functioning, that impermanence is the root cause of all that. That changeable nature is the root cause of all that. Now, there are people that are, very, very smart. And so what they figured out that there is no root cause, no single root cause of outages, right? And so they will say things like, basically, root cause is when you stop looking. Okay? And so that's kind of true if you approach it sort of from a top down. Where I'm approaching is from a bottom up. So in the bottom up, the sort of the most fundamental thing, the most indivisible thing is that impermanence. Now, some of you are wondering, did you walk into a philosophy lecture? Maybe theology, something? A little bit. We're going to be talking about Devops. We're going to be talking about antifragility. We will be talking about impermanence. These are all, kind of philosophical things. They're not tools. They're not job descriptions. I am an antifragile engineer. All I had to do was just say antifragile, and it just... See? And that's the root cause.
Yeah.
Thank you, gentlemen.
Thank you guys very much.
Thank you. Fantastic. Woo-hoo. So, where were we?
I think God.
God?
We got to some theology.
We have gathered here today. So, anyway. So, deserts, remember that? Change. 41 years apart. Change. Change. And I don't mean like computing change. The reason this thing functions is because of change. The reason computing functions is because of change. Compounded things are impermanent. The truth, not theology, not religion. What you call root cause is when you stop looking. I mean, fantastic thinker on the subject of complex systems, Sidney Dekker. But that's true, and there is a single root cause. Now, why think about impermanence? Is it useful? Well, it actually is. So the first thing with impermanence, we know, I can guarantee you, I can put money on this. Whatever system you currently have functioning will break. Right? So it's a useful piece of information because you can do something with that. And second of all, stop looking for the root cause of outages. You already know what it is. It's impermanence. Third, when things function or break, they don't do it randomly. It's not random. Meaning, like, if you're an engineer, you walk into a lab, you take 2 parts hydrogen, 1 part oxygen, mix them together, and you get ice cream. Too nerdy of a joke? Water, right? Right. So, we might as well give up our jobs as engineers if that's actually the case. So there are conditions that we can put together that will make the system function or not. Okay? And in fact, engineering is sort of the study of that. Is the discipline that studies what are the conditions that we need to put together to have the system function or continue to function, or the system will break. Now, we don't have control over all of the conditions, right? You guys have heard about the butterfly effect, and the butterfly, fluttering its wings somewhere in Africa, magically, kind of amplified and conditions, and all of a sudden you have an outage in Northern Virginia. How many EC2 customers here? So you don't have control over the butterfly, not at all. And you have a lot of control over whether or not your data center has, a backup generator. Okay? So we as engineers can focus on the things that the conditions that we can actually control. So let's talk about sort of an example. Let's say you have a file which contains the world's most valuable information. I don't know, maybe like a recipe for beer or something very, very important. And you want to make sure that no matter what, like that file, that information never disappears from the planet Earth, right? So the first thing you could do is you could put it on a laptop like that, right? And obviously, that file would be kind of fragile, right? It only would take one failure. Maybe a hard drive, maybe the baby, does what babies do, and boom, no file, right? And moreover, let's say everything's functioning perfectly, but you're connected to the internet over conference Wi-Fi, and two people try to get that file, boom, file is unavailable, okay? Now, usually what we think about is like, okay, so that's fragile, we don't want that. Our file is way too important for that. So we're going to think of something that's the opposite of that fragile thing. And usually, what we come up with is something like this. All right, so we got redundant power, redundant network connections, we've got like redundant servers, and maybe we're in different regions, and so if something happens on the East Coast, we still have it on the West Coast. Good. So we've made a very robust, we call it resilient system. And that's great, right? Because we can withstand lots, and because of the redundancy that we've added, we can withstand lots and lots of failures. And let's say all of your servers run the same version of Linux. And let's say it's that time when there's 61 seconds in a minute, the leap second bug. Anybody was affected by it? Yeah. So all of a sudden, all your redundancy that you built in, the different data centers, is kind of for naught. Now, this kind of an event, unless you're like the guy at Google who, modified the kernel to, compensate for that second, for that leap second, for most of us, this is what you might call a black swan event, like completely unpredictable. Right? There's nothing that we can do like now to think about, like to predict that kind of event. Okay? It's not based on sort of past experience. Okay? And so while this system, right, this thing that we built, can definitely keep this file safe and safer, it's definitely more robust, it is still prone to these kinds of black swan events. So in fact, there is a class of things, if we think about sort of the fragile system, right? So these kinds of systems, they hate disorder. They hate randomness. They want to stay away from volatility. They want to stay away from change as much as possible, right? This kind, they have a higher degree of sort of robustness to all those things, to volatility, to change, to randomness, to disorder, but up to a point. But there is a class of systems, a class of things that actually benefit from randomness, volatility, disorder, change. And those are called antifragile. We didn't have a name for it, but actually there's a lot of them out there. So imagine we took that file, we put it on the BitTorrent network. And imagine it became the most popular file ever, right? Everybody on Earth wanted a copy of it. Like, that kind of unpredictable event would actually ensure that this file is essentially indestructible, because it would be on everybody's computers, right? And you didn't have to pay a single penny more than whatever you paid to seed the file initially to distribute it. So in fact, this kind of system, the BitTorrent system, actually benefits from stress. That's another kind of synonym for disorder, volatility, etc. And so these kinds of systems, so like I said, we didn't have a name for it for a while, and we call them provisionally, I guess, antifragile. And they have this property. The downside, there's an asymmetry between the downside and the upside. Okay? So when we talk about, for instance, the BitTorrent situation, right? So minimally, the BitTorrent network is as good as the Fragile system, the single file and single laptop. Actually, probably even better than. It's probably minimally as good as a robust system because it gets distributed to a lot of different places, even when you first seed it. And maximally, right, if every person on Earth wants that file, no problem. It actually, it likes, the anti-fragile system like that kind of stress, like that kind of randomness, like that kind of volatility. Any questions so far? All right. So it turns out there's a whole bunch of anti-fragile systems in the world. So one of them is kind of book publishing, as it turns out. So this fellow published the book, The Satanic Verses, and pretty quickly got, what's the word, fatwa'd? Is that by the Iranian Shah or something? So, okay. What do you think happened to the book? Bestseller list. All right? So you put stress and kind of volatility and randomness on this kind of book, all of a sudden it goes through the roof. It likes that kind of disorder. Now, there's a fine point here. The guy who wrote it, he was kind of in pretty deep shit for a while, right? He had, technical term, you guys are all knobs, what? He had to have 24-hour protection, he couldn't leave the house, and all that kind of stuff, right? So this is another interesting thing about anti-fragile systems, is that there are layers of it. So on the book layer, the book greatly benefits from having this kind of, stress. On the author layer, the downside for the author is death. It's pretty serious. Yeah, and so this kind of layering effect, that's a layered cake in case you're wondering. Anybody hungry? It also kind of shows up. So, another system that's kind of has anti-fragile properties is vaccination. For a population, any vaccine people here? You will know who you are. Okay, anyway. So, for a population, right? So let's say the entire United States population. When we administer a measles vaccine, it looks like, the incidence of measles is decreased. So the population benefits. And there are individuals who basically might die from the administration of that vaccine. So this is like a very interesting anti-fragile property, right? So the downside for the population is very low. It's like 1 or 2 people or however many people will die from this vaccine. But the upside is huge. All of a sudden we don't have to worry about measles or some other, horrible disease. But for those individuals, it sucks. All right. So hopefully I've given you guys a little bit of a taste of this kind of anti-fragile systems. Basically, those are the systems that benefit from disorder, from randomness, that love stress. Bring it on. And they get better as a result of that. So how does it apply to DevOps and all that? So the question that I want to try to answer is DevOps anti-fragile? Where does DevOps intersect with anti-fragility and so on? And so the first thing we need to do is kind of talk about what DevOps is. Does anybody know what DevOps is? Does anybody not know what DevOps is? Baron. Thank you. So I will teach you. Nobody knows what DevOps is, right? DevOps is as DevOps does. How many of you are DevOps engineers? Come on, don't be shy. It's okay. Any heads of DevOps here? Really? Director of DevOps? My God, you're letting me down. All right, so DevOps. So John Willis, otherwise known as Bacigalupi on Twitter, he kind of coined this CAMS thing as a way to describe what DevOps is. Now, culture, automation, measurement, sharing. The measurement, automation, sharing, they all rest directly on the culture. So I'm going to spend a little bit of time talking about culture. Okay. DevOps, philosophy. It's a modern way of working. It's an organizational approach. Okay? Not a tool, not a job description, not a thing. Kind of like Antifragile, right? I mean, it's like... So the first thing that you will see organizations that appear to be doing DevOps, whether or not they will label themselves as such, okay, is they very aggressively manage downside. Remember from the whole discussion on anti-fragility, right? There's the downside, right? Trying to minimize it. And obviously maximize the upside, but first thing you got to do is minimize the downside. So, you know, it's kind of like this sort of airbag approach, right? Netflix, you know, kills live instances. They inject latency into their live production. So any people from Netflix here? No? Any people from Etsy? How many deploys now per day? 50? 50. Yeah, 50-ish. Last time I checked, it was like 40. So anyway, you guys are right on. So Etsy does 50 deploys a day. Pretty impressive. A company that we normally wouldn't think is DevOps, HP, they've been doing, they kind of re-engineered their software development process for their firmware, for the printer firmware, and they had an architect inject faults into the code so that, you know, they kind of would manifest and the engineers would fix it. Okay? So, like, what are the things that actually make these things possible? And if the answer is tools, probably, maybe. But tools are kind of like secondary. What really makes it possible is the culture. And what really makes that possible is this kind of asymmetry. The downside of a bad deploy at Etsy is like, okay, well, we'll redeploy a previous version. The downside of a bad instance at Netflix, no downside because Amazon gives that to you for free. But the upside, right? Get features to customers quicker, more market share, happier customers, all that kind of stuff. There's tremendous upside in moving this quickly. Okay? And so here's the thing that often gets overlooked, is how do these companies manage that downside? It's not the sexiest thing, right? QA, Netflix before they unleashed the chaos monkey and all that stuff, you opt in. It doesn't just do it randomly on the whole entire environment. It goes through testing. Okay? So there's very active, in all these companies, there's very active management of the downside. And we don't talk about this enough. Amazon kind of takes the cake, right? They do it so frequently and so well that they have an amazing defect rate. I mean, that's not really a defect rate. That's if a software is deployed and it causes a noticeable outage. That's amazing. That's quality. It's not only about the tools. Now, here's something that's even more interesting. So there's a company called Knight Capital. I think the previous speaker referred to it for a bit. And they did some stuff, kind of got in the news, and then they published kind of like, oh, hey, this is how we develop software. So if you read this, it sounds kind of agile-ish, right? Small features, kind of lots of testing, lots of QA. Sounds very responsible, right? You can't fault a company for doing something like this, especially one, I will give you, it's in the financial industry. But this turns out to be like as Jas Humble says, risk management theater. So, August 1st, 2012, 30 minutes, $440 million lost. One bug, supposedly. So this is actually one of the things. Nobody knows really what happened, meaning they're not publicly talking about it. Not a DevOps shop. No public postmortems. So what this actually means, so in the 2 days after they lost 75% of their value, they basically were sold in a fire sale. It does not exist as an independent entity anymore. This used to be one of the biggest, most profitable, they call it market makers in the world. Financial company. Basically printed money in the basement. And all it took is half an hour. So this is a classic black swan kind of effect. Turns out that system was fragile. They didn't know. Or maybe they knew, but they didn't think it was likely or possible. Probably they didn't know. It's really hard to predict this kind of an event. Impossible, in fact. But what you can tell about this is that probably they were not managing that downside. All right? So another thing about anti-fragile organizations or DevOps organizations, I'm kind of going to use them interchangeably here for a little bit, is this whole concept of skin in the game. So this is what usually happens. Developers take that code, all right, and on the other side of that little wall are operations people. And they receive this code as manna from heaven. And they lovingly cradle and deploy it and do all the non-functional stuff like security, like backup, like monitoring. Does this sound familiar to ops people in the room? Right? This is like many, if not most, organizations. They do this. We do this, not they. We do this. And so what's happening is, as a developer, I'm basically becoming, for a time, anti-fragile. Because by shifting all that stuff to operations, I've just reduced my downside. I got no downside, man. Who gets paged at 2 o'clock in the morning when the shit goes down? Not me. I'm sleeping soundly. I did my part. It works on my laptop. Right? And all of a sudden, in that transaction, the operations people become extremely fragile. Okay? Because now all they got is basically downside. So there's this concept of skin in the game, and this is what you would see, right, in DevOps organizations. In the organizations that I mentioned, Netflix, Etsy, Facebook, developers push into production. Sometimes directly, sometimes, I don't know exactly what Facebook does now, but if you're a developer and your feature is going out, and you're not around when it's going out, that's bad. You'll hear about that. All right? So that's skin in the game. And what happens when you don't have skin in the game, right? In that kind of scenario that I talked about, and it's beautifully and so depressingly described in the Phoenix Project. How many of you guys have read it? Good. Did you cry a little? Sorry. Feelings. Is as we start to deploy things less and less frequently, because we're trying to manage risk, right? Well, actually, as developers deliver shitty code to operations, the operations guys are like, whoa, wait a second, we're not going to deploy this. We're going to sit on it for a while. We're going to make sure, when we do deploy it, it's really good. And then, the number of features and changes that are supposed to go into production start to pile up, and then that makes the deployments even more risky, right? And then the operations people just say, oh, okay, well, we're not going to deploy for 6 months. That's it, done. right? This actually has killed companies, this kind of a downward spiral. And so it's interesting to note that, DevOps, right, the term, it actually contains like the antithesis, the very opposite of that in its name. And sadly, this is all we think about a lot of times when we talk about DevOps is, developers and operations and how to, get developers to have skin in the game and operations people to have skin in the game too, like that kind of thing. But it actually is bigger. It's about, getting the whole company, finance, HR, whatever, aligned towards the same goals so that there's no local optimization going on, right? So that the ops guys can't optimize for not being woken up at 2 o'clock in the morning, right? And so the devs can't optimize for just kind of like hands-off kind of, I did my part. It's functionally complete. And it's interesting that in these kinds of organizations, and I've talked about this a little bit before as well, you do need these comb-shaped people, and the reason for that is they're sort of the glue, right? They're the ones that are able to reach across these silos because they understand development, they understand operations, they understand HR, or whatever it is. And you find them a lot in these kinds of DevOps companies. People who have very ambiguous job descriptions. And it's interesting also that these kinds of generalists are actually, in a way, anti-fragile. So the downside for generalists is that sometimes they will be underqualified for very highly specific jobs. So because, hey, I didn't spend 20 years tuning Oracle or something like that. Okay? But the upside is huge. You get a much wider amount of many, many more opportunities. Okay? So being a generalist is kind of a anti-fragile. So the other thing that you'll see in these companies is a lot of tinkering. And Gene Kim calls this the culture of learning and experimentation, continuous learning and experimentation. And this the 3 ways of DevOps. Really great blog post, by the way. And so what's interesting is that we do a lot of planning in organizations, especially in big sort of hierarchical organizations. And, it's often done by managers and not by people who are actually going to do the work, et cetera, et cetera. And so what happens, it's not without benefit, the planning. But it's worth noting 2 things. One is, most of the breakthroughs that we've had in science and technology happened because of tinkering. Like penicillin was a mistake, was basically random. There's no way to centrally plan the development and the discovery of penicillin. And on the flip side of that, many a famine have been caused by the so-called central planning. Russia, China, North Korea. Okay? And so basically, what this tinkering allows us to do is discover, or some people call it farm, these positive black swans. We've talked about the black swans, the really negative ones, right? But they're the positive ones, like the discovery of penicillin, which has changed medicine, changed the lives of all of us here. And you do that by doing constant small experiments. And the reason that's possible is because of that anti-fragile asymmetry. Because, the cost of any one experiment failing, and most of these experiments will fail, is very low. In software teams, this is why the iterations are short, maybe a week or 2 weeks, because, hey, if whatever we did in that week or 2 weeks didn't work, no big. But sometimes those very short iterations, those small bets, those small investments, that tinkering, actually results in huge positive black swan kind of thing. And this is illustrated by, at Google, you guys heard about their 20% time? Turns out that 50% of the products came from that time. Gmail, Google Talk, AdSense gives them nets 25% of Google's revenue. So it's brilliant, and it's an anti-fragile kind of strategy because you're limiting your downside. 20% of engineers' time. That's at the most it's going to cost you. But the upside is huge. So DevOps, right, CAMs, measurement and automation. I already mentioned, I think those things are incredibly important. And there's some danger there. How much, if you got on an airplane and the pilot could only fly on autopilot, right? It's kind of scary. What if your deployment system, your automated deployment system, your configuration management system is not available? Does the organization know how to do things manually? If not, you're fragile. You're opening yourself up to that black swan, that unpredictable, rare event that will knock you off your feet. And of course, sharing is caring. So what we're all doing here actually is kind of anti-fragile because we all, in our jobs, on a daily basis, we fail. When we publish our results, as postmortems, the whole community gets better. It's kind of similar to air travel. When there's an accident, it's kind of bad for those people on the ground and in that plane, but the whole airline industry actually gets safer. And that's also anti-fragile. I encourage you very much to read this guy's book. He's a little funny. And if you want to talk to me about this, I have office hours tomorrow at 10:45.
Thank you all.